All right, guys, number 39 is a problem that I expect would annoy you guys a lot if you remember how to actually evaluate definite integrals from last year at the end of pre-calc. However, that method that you learned back then, if you do happen to remember it, is not something we've covered in here yet in section 5.2. So the directions here are just telling us to use the properties of the integral and the formulas in the summary here, basically what's in your notes, to calculate those integrals. So the formulas we're going to be using here, guys, if I remember them right, were something like this, like an integral from 0 to b of whatever variable you were talking about here. Like, for example, if it was x squared with respect to x, was going to get you, let me see if I've got this right, guys, it was going to end up being a 1/3 and then a b cubed for that one. There was a similar version, the integral from 0 to b of x dx was going to end up being a 1/2 and then a b squared. Those are really the big ones right there that we're going to play around with right here. But I want you to notice that both of those formulas have to have 0 as their lower limit of integration. If you don't, then these formulas don't really apply. Well, this integral they're asking us for here, guys, doesn't have 0 as a lower limit of integration. It's the integral from -3 to 1 of 7t squared plus t plus 1 dt. So how are we going to get around that? We're going to split this integral up using the additivity property that we covered in section 5.2. So we're going to take, first of all, this integral starting at -3, but we've got to end it at 0. And the integrand is going to stay, exactly the same. 7t squared plus t plus 1 taken with respect to t. Then we add to that now a second definite integral that starts where the last one left off, at 0, and then we end that up here at 1. Same integrand now, 7t squared plus t plus 1 taken with respect to t. Now, this second integral is already in the form that we want, 0 on the bottom and some b value, in this case 1 up on top. But the first integral, the limits are backwards. So let me slide over to the left. What we can do then, guys, is reverse those limits. We can move 0 to the bottom and -3 on top, but that then puts a negative out in front of the entire thing. So that's another property from our 5.2 notes on reversing the limits of an integral. Now everything else stays the same. 7t squared plus a t plus a 1 dt, and I'll leave that second integral alone just the way it was. Integral from 0 to 1 of 7t squared plus t plus 1 dt. Now, what I'm not going to make you do here, guys, is a serious pain in the butt. I'm not going to make you split this up into 3 different ones, because really we should write, oh, this is no fun, the opposite of the integral, don't write this down, 0 to -3 of 7t squared dt. And then what? Plus a negative, so minus an integral from 0 to -3 of t dt, all right, and then minus an integral from 0 to -3 of 1 dt. I think you guys can just kind of understand that that's what we're doing without writing it down. So where are we going from here, guys? First of all, this negative out in front, I don't want to lose sight of that. I'm going to put a negative and then a big set of brackets. Now, constant multiple rule, that 7 right there means that my answer just starts with a 7. And then here we go. The integral of t squared, we said, or in this case x squared, right here, is going to equal a 1/3 b cubed, where b is your upper limit of integration. So this is a 1/3 times your upper limit, which is -3 cubed. And I'll clean that up on my next step. Then we've got a plus. Now, the integral of t, a linear function, I did right here, that becomes a 1/2 b squared. So that is going to be a 1/2 times b, your upper limit, which is -3 squared. And almost done here, plus, and I think this was a property here as well, the integral of a constant, everybody, is just going to be whatever that constant value is, which is 1, multiplied by your b value minus your a value. So -3 minus 0. And all of that takes care of this integral right here. But I still have a whole other one to worry about now. So I'm going to go plus and another set of brackets. And let's do the same thing now. The integral of 7t squared, it'll start with a 7, and then t squared, that integral is a 1/3 b cubed, b being your upper limit of integration. So 1/3 times 1 cubed. Plus the integral of t, okay, in this case, is going to be a 1/2 times b squared. B, again, is 1. So 1/2 times 1 squared. And then plus the integral of that 1, the height of this rectangle is 1, and then it's b minus a, 1 minus 0 for the width of that. All right, this is messy, but we're getting there. So I've got a negative out in front and a big set of brackets. Ugh. Negative 3 cubed is negative 27. Divided by 3 is a negative 9, times 7 is a negative 63. Ugh. Next, negative 3 squared is 9. Half of that would be 4.5. So I'm going to go plus, I'll just leave that 4.5. There we go. And lastly, negative 3 minus 0 is negative 3 times 1. That's a minus 3 there. That is not all that pretty. But keep going. I'm right here now. Plus, let's start that second set of brackets. 1 cubed is 1 times 1/3 is 1/3 times 7, 7/3. Plus 1/2 squared is 1 times 1/2 is 1/2. And then plus 1 times 1 is 1. So boy, this is getting kind of ugly right here, but we're getting close, I think, guys, to the final answer. Silly as it seems, I don't want to goof this up. I'm going to distribute that negative in here and get a positive 63 minus 4.5 plus 3, and then I can just leave off the brackets right here, plus 7/3 plus 1/2 and a plus 1. Now, what's going to happen next? Looks like I've got 1, 2, 3 whole numbers. I'm going to go ahead and put those together. You obviously could just type all this into your calculator, guys, but where's the fun in that? 63 plus 3 is 66, plus 1 is 67. Then I've got negative 4.5 plus 1/2. That just becomes a negative 4. And then a plus 7/3 that doesn't really combine with anything. So 67 minus 4 is 63 plus, and then 7/3 is 2 1/3. So I've got a final answer here, guys, of 65 1/3, which should be our final answer here for problem number, I can't remember, this was number 39. So that is definitely tedious, everybody, and relax, we're not going to do this very much because starting in 5.3 and getting into 5.4, we're going to learn a much, much faster way to come up with that result.